All right, hi, welcome to Dev Better, a series where we talk about software engineering problems that we've encountered in our travels as a software engineering consulting firm. Today, we're going to have a chat about ECS, Elastic Container Service. We're going to chat through some fun things that we've seen when working inside ECS on top of Amazon. And today with me, I have Brian and Ahmed. Let's go through real quick. Say hi, guys. Let's start with Brian.
Hello, my name is Brian Voskerijian. I've been a software engineer at 7Factor for just under a year now.
Awesome. Ahmed?
Hey guys, my name is Ahmed Ismail. I'm an engineering manager, but I started at 7Factor about 3 years ago.
Got one of the OG 7Factor crew. Thanks for joining me, guys. We're going to have a chat here. Let me bring up my notes. We're going to talk through some fun things. So first off, let's kind of talk about why we do clusters, right? I want to describe the problem for everybody. What is a cluster? A cluster is basically a way of taking multiple machines and running things like Docker containers on top of them. If you're familiar with Kubernetes or ECS or any of that, these are all clusters, more or less, right? And so the advantage of doing a cluster is that you can run more software on less hardware. Thanks to things like Amazon, we have the commoditization of software these days where, again, you have ephemeral environments up in the cloud. You click a few buttons, all of a sudden you have this massive amount of machines that you can do all kinds of fun things with. And so ECS was a product that came out, I don't remember the exact number, maybe 5 or 6 years ago, but it was a really cool idea because this was before Kubernetes was really kind of the big deal thing that people were doing, which Kubernetes is fine. It's very complicated, but it's a really good system if you need the complications that are inside of that system. But ECS is kind of a poor man's Kubernetes in that it's a really simple way to spin up in machines and then place Docker containers on top of those machines. And so I have this silly analogy that I tell people when I'm explaining what ECS is, and basically it's buckets and marbles. So each of the ECS instances or EC2 instances with ECS software installed on it are the buckets, right? And these buckets have hardware capabilities, some number of virtual CPUs and some number of RAM on top of them. And each of those machines are spun out in an auto-scaling group, and you have n of them, and where n is equal to the number that you set on the min-max desire. Or if you're using something like a capacity provider, it will actually kind of figure that out for you. But we've had some weird things happen with capacity providers, so we kind of aren't using them these days. But it's a good idea if you need a cluster that just magically scales horizontally as necessary. So each of these buckets has a capacity, just like you go to Home Depot, you buy a bucket, it holds a gallon. In the ECS world, each of these buckets has some number of CPU and it has some number of RAM, right? And so from there, we want to take our marbles, which is our Docker containers, and put them into those buckets in order to span our services out. So when I develop a piece of code that's an API that I wrote in Java or .NET or Python or whatever your favorite flavor is, and I create a Docker container, I can now put this out into the ECS cluster, and ECS will manage that. It will horizontally scale it for me, and it will do what it needs to do, right? Vertically scaling in a cluster is basically getting a bigger bucket, right? You buy, instead of 2 virtual CPUs and 8 gigs of RAM, you go up a horizontal step to something like an M5.extra large, and now you have 4 virtual CPUs, and you have, I think it's like 13 gigs or some weird number of RAM. So that's the general idea of what a cluster is. There are other ideas that you have to understand that I'm not going to dig into very deep in this conversation, but things like port mapping, health checks, target groups, and this is if you choose to run your own cluster. Amazon also has this concept of what's called Fargate, which is a magical cluster in the sky that they manage for you. They handle patching, they handle software upgrades, they handle all of the capacity, and all of that is built into. Now, this is more expensive, and it's something you kind of have to account for. Basically, the reason you're using clusters is so that you can save yourself some money, right? You're running multiple pieces of software on the same hardware and scaling that hardware out horizontally a little bit better than if you had one particular piece of software running on each individual machine. But at the end of the day, you have this nice grouping of buckets and marbles that are owned by somebody, and you can push stuff out, scale it horizontally, scale it vertically, do whatever you need to do. And there's a lot of complexity around that. But again, we just want to talk today a little bit about our experience and how we have scaled ECS clusters in the wild when we work for clients. And we have 4 questions that we're just going to talk through today and discuss again, and the things that we've seen in our travels. All right, so let's jump into the questions. The first one that I want to talk about is, number 1, how do we size tasks appropriately inside an ECS cluster? And I just want to throw it to the team here. I can give my experience as we go, but how have you guys seen sizing in your travels? How has it been difficult? Or maybe talk about a time that y'all have sized a cluster when you're working on a particular Docker service.
Yeah, so there's not a one-size-fits-all answer to that. I think the nature of it is you just need to understand the requirements of your application, what it's supposed to do. So there are a couple pieces that go into that. Number 1 might be what framework or technology that you're using. Different technologies have different requirements. Java Spring might need a little bit more beef for you to run versus something more lightweight, so on and so forth. Another piece is what are you going to actually be doing? Are you running some sort of very complex algorithm that would tell you that you might need to add some more CPU resources? If you're doing a lot of ETL jobs like we do, you might need to know ahead of time that you're going to need memory, because what you might be doing is extracting a bunch of data and then doing some processing on that data while it's in memory before loading it somewhere else. That is something that we have tripped over on the past. We have old legacy applications that we've converted into a container, put on ECS, and found that it kept tripping over itself because of a lot of operations that it was doing that were very memory intensive. So in the end, we decided to logically separate that application into its own cluster that, and we might get into this later, but had instances that were very memory optimized. So they just gave it a lot of memory, basically, so that when ECS saw that it needed to run this task, it had the reserved space in the EC2 instances. Does that answer the question?
Yeah, great points. And so one of the things you'll also run into is the difference between transient workloads. So you mentioned ETL, right? So let's talk about transient workloads versus API workloads, like stuff that just kind of runs there. You mentioned you were doing ETL. That's oftentimes a good pick for Fargate, right? So talk a little bit about how you might pick where you're going to put your workloads in something like a Fargate cluster versus an ECS cluster.
Yeah, sure. So a long running task, so the concept of a service, I think, was really created for this, is to allow you to configure settings for typically long running applications like an API layer. So you can, for example, set the minimum number of tasks that you want and the reserved resources that you need for something like that. For services that are going to run, on a schedule, do a thing and then turn off. It's nice to have the ability to just use Fargate for that, which I look at it as sort of a connection of like a serverless workload on a cluster of containers at the same time. So with that, we can just let it handle the resources for us, whatever is going to be needed for this workload that's going to kind of just shut itself off after it's done is going to be held for us, and can turn out to actually save us money in the long run versus having us handle the workload ourselves.
Yeah, absolutely. So,
Brian, you have anything to?
Yeah, Brian, you got anything to add to that?
Yeah, I'll just piggyback on that. The Fargate tasks are really good for those one-off tasks that may be infrequent because you're not paying for it unless it's running. Whereas if you try to run that on your cluster, it might be cheaper per hour or per minute. But you have to worry about questions like, okay, I have to run this at 5 o'clock on weekdays. What's going to happen to my cluster? Do I have capacity at that time? With Fargate, it doesn't matter. You just run it and Amazon takes care of it.
Mm-hmm.
Yeah, I've often seen that Fargate is great for transient workloads, and ECS static is good if you want to run APIs behind the cluster, right? And again, Amazon's going to push you towards using Fargate because they're going to make more money off of that, and that's okay. And there's good things about it, and it's a great platform to use. But I oftentimes think that if we spend maybe 20 minutes understanding how these clusters run, you can save yourself on the order of 10 to 15% over the cost of a cluster for the long term. And a lot of the times we see people sort of miss sort of getting buckets that are too big. Rarely do you see people build buckets that are too small, because if they're too small, you can't deploy to them, which is something we'll talk about in a minute. But a lot of the times we see folks that are over budgeting capacity in their clusters, where they'll have like 4 virtual CPUs and call it 16 gigs of RAM, and they're only using 6 gigs of RAM across all of their machines and like 1.5 virtual CPU. And so you're spending a ton of money on hardware that you're not using. So there's always an exercise that I like to take after we build out the cluster and we think through the memory footprint, as Ahmed was saying, of the applications that we're running on, and we figure that out. Then we go through an exercise of resizing clusters, because you kind of don't know what you need at the beginning, right? You may not understand the data workflows in a given app, or how .NET operates inside a container, or Java, or anything like that. Each of these frameworks is totally different, right? So you want to be able to understand how those things work inside those containers, inside those Docker containers that get pushed out into the clusters themselves, and then resize it as appropriate. So next question, how do we size services appropriately and make sure that everybody's playing nice? And this piggybacks well on the task idea, because tasks are simply something that's instantiated by a service. Inside Amazon, you can have multiple tasks that multiple container definitions rather, that live inside a task that works with a corresponding service. But then the service kind of owns the load balancer, the target group, and all of the port mapping stuff. So what do you guys think? How do we size our services appropriately, knowing that we have n tasks that are in different instances of a task that might live underneath that?
Mm-hmm. Yeah, I think it's a continuation of the same idea. So if you have a minimum number of tasks that you want to run, for example, you need to understand that you need to have reserved resources for that, and specifically as well for the number of tasks that you set up for the service to be able to scale to, if that makes sense. So for example, if I have a service that needs to run 2 tasks at all times, but in times of peak performance or operation that we need 2 more tasks, then we need to make sure that there's enough resources set up in the instances if we're using EC2 in a cluster to do that. I don't know if we want to get into how that works with application load balancer and dynamic port mapping, but that's all kind of cool as well.
I think maybe a brief discussion of that would be good. So maybe you want to cover that real super quick.
Sure. So it's nice because we kind of get all of that baked in as part of how services work. So we can assign, if you're using an application load balancer with a service, one problem that you have with running multiple instances of the same application is that they all have to run on different ports. So how do we make sure that, when a user hits an API, that they are routed to the proper application? So we get what's called dynamic port mapping, which is a setting that we can set up via the app load balancer. And that will allow us to have a mapping between the endpoint or the source and the destination from one port to whatever ports are set up, which can be different each time a task is run. and the app load balancer handles it for us.
Right. I've seen a lot of anti-patterns where people that walk into ECS for the first time will try and configure their ports directly. Like they're used to their container running on port 80 or 8080 or 8000 or something like that. They try and deploy this out into a cluster, and you fail to remember that a computer can only give up one port at any given time of the same number. So if we place two tasks on the same machine, which is the entire point of doing a cluster, is to have multiple tasks running on the same machine, then you are automatically colliding, and you can't place any additional tasks on that. It'll explode. It won't be able to do the deployment, which is where the ephemeral ports comes into play, right? Where ECS will magically say, okay, new task, you get port 56123, but we're mapping that to the application port on the container of port 800 or 88 or whatever you would so choose for that to be. So that gets you, again, that horizontal scalability and having multiple tasks running, again, multiple buckets in the same marble to use multiple marbles in the same bucket to use my silly analogy. So to follow on question, you guys talked earlier about basically spinning a service off into its own cluster. So that's a strategy that we need to employ at times, and it's dependent on the footprint of the service itself. Maybe talk a little bit more about that and tell me how you guys decided to do that.
So I think what we found in our experience is that we've found this useful when we have tasks that are really very different in nature. So for example, we have some tasks that require a lot of memory. So we run those in their own cluster so that we can size those buckets, if you will, appropriately. We don't want to go and oversize one cluster and give it, throw a ton of memory at it, when most of the tasks that are running in that cluster don't require those resources. So we take those tasks, we spin them off into their own cluster, we increase the buckets, we size up those buckets so they can handle those tasks, and we leave the main cluster alone, where those buckets can be smaller. We don't need all that memory, so we're not paying for all those resources.
Right. I think the important thing there is noticing that a service is a special snowflake at times, and it will be. The flip side of that, taking this too far, is stating that every application gets its own cluster. Now, this can be valuable because you're going to reduce the amount of money you're spending on the EC2 instances that are running, because maybe you have 4 tasks running on 2 machines, right? And that's better than one task running on 4 machines, because you're, again, spending less money on the hardware. But you do want to avoid taking that to the extreme where now every single application has its own cluster. There are cases where this might be what has to happen, though. Again, depending on what your marble looks like. It may have very specific special needs. It may be very CPU bound. It may be very memory bound, and you do want to provide it what it needs to operate efficiently in the field and at scale. But I like to run mixed clusters. I mean, maybe I'm wrong on that, and people feel free to point out if I'm wrong, but I like mixed clusters because they're cheaper, better, easier, and generally just much, much simpler to manage at times.
I think another thing that factors into this is business requirements around availability. So we can use placement strategies to make sure that tasks are placed across different data centers or availability zones, right. Basically across different EC2 instances in those availability zones. We can also have a secondary order of a placement strategy to make sure that they are packed in as efficiently as possible using their memory requirements, so on and so forth. So that kind of factors in, I think, as well into what type of instances you have in a cluster and why you might choose to put a service in one cluster versus another.
For sure. Awesome. Let's switch gears here. 2 questions left, almost done. So let's talk about how we manage deployments. And Amazon actually has a pretty slick way to handle this. But there are some gotchas if you're not using the stuff that's built into their ECS platform. We use Concourse. We did a previous episode of That Better on why we use Concourse and Terraform to do basically all of our deployments and create all of our infrastructure. So we have to maybe approach it slightly differently than if you were using the native Amazon stuff, which means we have to think about what our cluster is doing. So talk to me about deployments, guys. How has that gone for y'all?
Yeah, overall, very smooth. I mean, we used ECR. Maybe I'll talk about some gotchas and some things that we ran into.
Cool.
So, issues that we ran into, I've noticed, have been around rollbacks. So, in order for us to roll back, we basically take an image that's already been pushed to the container registry, and we launch it back up into ECS. We start that task. We ran into issues where we didn't keep a long enough history of images in order to be able to roll back. So we ended up having to rebuild that image, which isn't the craziest thing in the world to do, but depending on the reason why we need to roll back, it could be more of time commitment than we want to take on.
Yep.
So that's something that we've had to adjust for in the future, is making sure that we have a long enough backlog of images in ECR in order for us to roll on our deployments quicker.
Something I've run into is the dreaded you don't have enough capacity problem, where I'll attempt to deploy a task and it'll try to place it, but it silently tells you it can't. And this is kind of a thing with Amazon that bothers me, and maybe there's some ways to set up some event bridge stuff to notify me when this happens using some lifecycle hooks. But at the end of the day, I push something out and I don't have enough capacity in my cluster to spin up a new version of that task, right? And there's this min healthy % idea inside ECS where it says, okay, I will only ever kill enough machines to meet your min healthy % requirements. So for example, if you have 100% min healthy request and you want to spin up a new version of your task, you have to have double the capacity in your buckets, right? Because it means I'm forever going to keep 100% of these tasks healthy before I place new ones. So that means deployments require double the capacity. So you have to kind of tweak that number. But there's been a lot of times where I've pushed something out, it's silently failed. And I'm hitting my website or I'm hitting my API and it's like the old version. I'm like, what's going on? Why is it the old version? And it's usually, again, the old version because ECS is not going to kill that. Which is a really good thing. Thank you, ECS, right? It's not going to kill existing versions of the task when it can't place new ones during a deployment. So that's a really good feature of ECS, but it's something that will sometimes bite you, and it's certainly bitten me. All right, so let's go to the last question here. How do we scale our clusters? There are ways to do this that are built into ECS. So talk to me about how you guys have scaled, both horizontally and vertically.
Yeah, so horizontal scaling, that's one of the places where ECS really shines because, the simple situation is you're just modifying the number on the service that specifies how many tasks you want. So, if you want to go from 1 to 2, you just change the number and ECS takes care of it. So that's really nice.
Mm-hmm. Yeah, for us, it's even a bit easier than that because we use Terraform or infrastructure as code. So it's a one-line change. If we want to go from 2 to 10,000, it's still a one-line change. So that makes things very nice. So, we change the code. We have it go through our pipeline, which also runs the Terraform for us, and the changes in. With vertical scaling, it's a little bit different, but it's also just a change in the Terraform. I believe the cluster itself has to be re-terraformed, but again, with the nature of the whole point of why we're using it, that should be something that is expected to happen. We want our clusters to be able to be re-terraformed at any time, and that's one of the reasons why we use infrastructure as code and ECS together.
Right. Vertical scaling events should be pretty rare from what I've seen, right? Because generally you want to pick the most economical bucket that can fit the most marbles that are of the color, size, and shape that you care about, right? So generally when I've worked in this, when I've worked with vertical scaling, it's been because we've gone through an exercise and we've figured out that our buckets are the wrong size, be it too big or too small, and we re-terraform the entire cluster to rebuild all those buckets. Now, there is a challenge here. this will cause some form of downtime in your cluster, because re-terraforming an auto-scaling group right now is a bit barbaric. It's kind of like, slamming into a wall with a sledgehammer. It just completely destroys everything in your cluster and then brings everything back, and it doesn't really do so very gracefully. So you do have to take that into account when you're doing it. But again, those vertical scaling events should be rare. You should not be retooling your cluster every day or so, because then maybe we're not, maybe we're doing it wrong. But hey, thanks guys so much for joining us. This was a great conversation. Brian, Ahmed, really appreciate your time. Thanks for giving us your wisdom and sort of tales from the field as we're fiddling around with ECS clusters. Hopefully this information is good for everybody watching the video. Appreciate you guys coming and hanging out with us for a little bit. And we'll see you guys on the next episode.